modify according to whatever the values you want to be passed after word embeddings. Yeah, let's go with the sets. Data such as having with the sets, this number of the sets we had, it contains maybe the alphanumeric or maybe the numeric or alphabets, that does not matter. We just have the set of the words. It's going to be identified with regarding some of the operations like union, joints, left joint, right joints. We already know, right, some of the, you can say, sets operator. If you have a two sets, if you have a two sets like Venn diagrams, you know, right? If you want to apply the outer join or the union operator, it will throw give all the values corresponding to the set A and the set B. So similar concepts with regarding the left join. If you apply the left join, what will happen? Corresponding to that left join, right? So corresponding to that, you eventually going to be get only for the left out whatever the values we corresponding to do that. Similarly, the route join, you will going to be get all the values route join. If it is not present or the based on the condition, it may not be present. Only the left value is going to be empty with corresponding to that. Similarly, the inner join. Yeah. So similarly, the inner join, we also know that whatever the common values we had, so it's going to be showcased as this range only. So we can perform some of the operations. If suppose you have an application with respect to, you want to be showcased as a number of the words or number of the frequency of the words, okay, as corresponding to transfer learning and embeddings makers. So how do you combine with those things? By using the set only. Okay, so defining some of the list and tuple, then we can play around with this. I'm defined some of the list and also the tuples. Yeah, you can see. Yeah, you can also convert maybe by using list to tuple by using the set operator. This is also very works out well. So yeah, if you want to add any kind of the element in a set, you can add, maybe it will be adding at the end of the sets. And delete also works out well. You can, if you want to delete, you can delete, and the set index is going to be it will be helpful to this operator, okay. But if you delete this one, it's going to be set as an index to the corresponding to B, then it's going to be incremented with the other and other. Similar content works out with the tuple and the list also, whenever you discard or remove. Yeah, so the basic difference between both of them is whenever you want to be discarded, okay, the element is going to be not present at the time of the set, you can discard it maybe. But if you want to be removed, you want to be know about that the value is present inside the tuple or inside the sets. Otherwise it's throw error, right? The X is not present in this list, in this sets, okay, it may not be possible to get this error. Yeah, differencing, you know, right? If you want to be differentiated for the X A comma B, you want to be differentiated, it will throw only the A values, I mean corresponding A values, and whatever the corresponding, you can say the common values, if you're going to be differentiated. So in this set you can take, so set 1 and set 2 be declared with corresponding to this. So you can see all the values are common here. So if you want to subtract both of them, it will give as an empty set. If suppose if the values are having A, B, C, okay, in a set 1, it's going to be give the corresponding values of the A, set A only. Okay, so yeah, so difference update also going to be help us. It will compute the difference, and then it's going to be updated value into the set A. We are just declaring some of the value with corresponding to the sets. Intersection also will be the same. I just now spoke about the inner join side. So similar concepts is going to be worked out with the intersection. Whatever the common values we had with corresponding to the two sets, it's going to be jumbled together. So these are the two sets we had. If you apply the intersection, so common values 1, 2, A, B, C. Okay, 1, 2, A, B. You're going to be get the similar output according to that. Intersection update, we're going to be update corresponding to this variable. Yeah, so these are very interesting operations, disjoint and subset and superset and the union. So let's play around with this. Disjoint is going to be help us whenever you have a sets with corresponding to, you can say the set 1 having set 2. So if we just applying the disjoint set, it's going to be give what are the common values, or you can say what are the some subset of the values is going to be joined together. Currently, we don't have any sub points, right? So if you apply the A also, it may not be possible to get the values. Similarly, you can see is disjoint with corresponding to B. More often, all the points are completely different according to that. Yeah. So yeah, upset set also will be the same. You can see the number of the values. It will be add some of the values. It may not be present with the some of the original values. Iterate also will be the same. You can also apply to iterate some of the sets. So these are